Hello everyone, today we are going to demonstrate our distributed system final project. My name is Igusti Ayu Pratnyasa Devi Sastrawan and my student ID is 2315101020. And next,
And my name is Iyaman Putra Satyanata, with student ID is 23151101010. And next,
And my name is Putu Raditya Satriawan with the student ID of 2215101005.
on the assessment criteria, we implement the quiz assessment submission case study. We name this application QuizNet. It allows real-time interface interface between admin who create the quiz and student who take them. Right now, you are looking at the front-end interface. Every action that happens in the browser, I click the Save button just now. Fully implements REST API. Our front end set HTTP requests like post and get directly to our main system gateway. Before reaching the gateway, the request goes touch NGX. This fulfills the API alert listening criteria. NGX works as a traffic director that distributed the Lord Evelyn using the Rubin method to our three API gateway containers. Because of this, even if thousands of students click at the same time, the system won't crash. Okay, next, what happened behind the gateway will be explained by Satya.
okay, thank you, Sachi. After passing through the load balancer, the request goes to the backend, which is designed using a microservice architecture. In our architecture, the functions are split into the quiz service submission service and the notification service. Because they are spread, we implement the service-to-service communication using RPC or the REST or STUB base. This means that the API gateway does not process the quiz logic itself, but instead call this internal service through a dedicated proxy or stub. Of course, all this quiz and answer data must be stored permanently, and therefore we implement the present store using a database. We use PostgreSQL, where is a microservice like the quiz, submission, and notification has and maintains its own database table independently. The quiz has just been submitted. You can see that the status is pending or the status is grades haven't been released yet. Why is that? The secret of this asynchronous data processing will be explained by Radit.
Okay, so thank you, Satya, for the great explanation, and also Sachi for the great introduction explanation. So, you can see here through all of our process and all of explanation, after the last test is submitting the student's answer. This is where the Rabbit MQ takes places. So the Rabbit MQ here is integrating the asynchronous workflow criteria, and when the system when the students, for example, submitting a test, a quiz, it will not directly get the result and the notification, but instead it will go first into the Rabbit MQ queue, which is a background worker that picks the data up, calls the quiz service via RPC for the answer key, and grade it. And once it's graded, it sends another message to the RabbitMQ, so the notification service can be sent to the student page without interrupting the main website itself. And that is when the asynchronous task is taking the place. So, for that is the RabbitMQ visualization. You can also see here, which are what is how the RabbitMQ works. There are two connections, two channels, and also all of those configuration here. You can also see that this is already working for the asynchronous process and also calling the RPC one. And here, let's go back to the main pages, which is admin check the place. And here, to meet the criteria for this project, which is we need to implement the leader election algorithm. In here, we are using the ring-based algorithm, specifically the Chang-Roberts method, which here I already also state here I use I use 5 nodes, which are each node represents each API gateway, which are balanced its load using the engine X that's explained by my friends before. You can see here the engine X one, the configuration. Sorry, the configuration one. You can see here there are 5 of them to balance the load. And also here, because I use a ring base, which are getting the ID and voting for the biggest ID, check for the biggest ID one, we can see here that we have 5 nodes and the current leader is 5 because all of our nodes is online. But we can test now, what if we turn off one of the node, which is the leader node, we will turn off first. This is the API gateway 5.1. We will stop this process via the Docker. And we will see here, it will automatically refresh and it will automatically do the election. Here you can see it do the election. And you can see now the current leader must be 4. Yes, it is the number 4, the node 4, which is the current leader. And this process is mainly focused on how the leader election works, the ring based, because here is just to check whether the biggest ID is present or not and which one is the biggest ID. We can also check via the command line. The command line here is the command docker logs. We are using the logs to UAS API gateway. Let's say sorry that, and we can see here the election process, starting election tree, and also node 1 leader realized that node 5 is unresponsive, and that is starting new election, and receive coordinator message leader 4, and so on and so forth, and it will ended up in the current leader of node 4. And if we test again, if we turn back on this node 5, the API gateway 5, it will automatically going back the current leader to node 5 because it realized that that there are new nodes, there are changes in the node's configuration, and it will automatically change to the current leader of 5. And so that's basically all of our explanation regarding our website is QuizNet that submit a quiz, making a quiz, and etc. using the distributed system. And must be so much things we can improve from this website, including the login system, etc. But here is the most ideal one to experiment or to demonstrate the distributed system, how to elect the leader, how to use Docker Compose, and etc. So thank you for watching the video. Thank you for the great explanation from my friends, and we'll see you on another chance. Goodbye.